Well, hi, good morning, and thanks for coming and joining me in my shop here. It's December, holy smokes, it's December, no, 9th. I almost said it was December 12th. December 9th, that makes me feel a little bit better. So, what am I going to do with this radio? Oh my gosh. So I'm halfway through doing basically a standard repair or simple restoration on the radio, changing capacitors and that. And I've encountered sockets, tube sockets, that appear to have some inherent problem in the socket itself. Am I absolutely convinced of that? I'm like 95% convinced of that. Could it be something else? I have conflicting tests. One of the ones that's really disturbed me, I did in the last video, where I tried with an ohm meter to read the resistance through the pin and the contact and down out the bottom of the socket, and the results of that was the socket behaved perfectly consistently as I pushed the tube. It was actually a socket extender in and out of the socket. The reading was stable, 0 or nearly 0. I didn't see any of the jumpiness I thought I was going to see. So with that piece of information, it's just one pin on one socket. That information suggests there's no problem with these sockets. Yet every other thing I've done suggests the socket itself internally has a problem. So I examined a bunch of sockets in the last video. I saw that in every case the socket uses a continuous piece of metal from where the prong goes in to where the terminal is sticking out down below. It's this continuous piece of metal. And what I suspect is that these sockets are not that way. That they have two pieces of metal, one up something like this, that the prong goes in, then there's some kind of mechanical connection made here, something is done here, and then out the bottom comes what I believe now is a piece of wire, or a wire-like, could be a piece of steel, I don't know, it wouldn't be a piece of steel, but something comes out. It's not a wide tang like you see in most cases. It's a wire. And why? Because this is mounted on a board. Most of the things I'm working with are point-to-point wiring. The sockets are screwed to a chassis, and the connections are all down below. This one, when you put this on a board, it is the connection to the board right away. So it's a little bit of a different deal here. So the way forward with this, one is, well, that's it, we're done. Two, there's some capacitors in here that should be replaced. Can that be involved in this issue? I ran this around my head at the end of the last video and concluded that, yeah, I guess if you really click your heels together 3 times really hard, you can see how just maybe bad capacitors could cause an effect which would appear to be a defect in all the sockets. But really what it is it's the radio becoming sensitive to normal sounds that would happen if you move the tube a little bit. And if I correct that sensitivity, then this noise will go away on all the tubes. And a more detailed theory on this would be perhaps something like the B+ line or the screen line is not being cleared of noise. It's a capacitor that's supposed to clear the line of noise, if I can put it that way. It's kind of a bad way of putting it, let's put it that way. They're not clearing the line. And so noise is being transmitted up and down through all the tubes, these tubes with screens, or all the tubes with, they all have plates. And so it doesn't matter which one you wiggle, any one of them will set up this scenario. That's another theory. So the great thing about that theory is that there's a fairly simple fix, if you like, and that's to change a few capacitors. Get that done and see if that just magically makes everything work properly again. So that's a lot easier and a lot more valuable. Push the value of the radio up a little bit, having done the capacitors, even if it's not working right, still. And low risk. I don't think it's any risk. Just take a little bit of effort to do it. Now, there's 2 capacitors that are in a suspicious location. So these tubes appear to be the most sensitive to this problem. And there's a big old capacitor there, and there's another one kind of hidden around here. Aside from that, there's one over here. It's pretty easy to get at. And wasn't there another one? So there's an electrolytic one here I'm not too worried about, in fact. Beyond that, there might be the smallish capacitors all in here, I believe, are high quality ones that tend to not fail, but I'm not sure of that. These ones are low quality, for sure. And the one you can't quite see back here is also known to be a failing kind of capacitor. So I'm going to do that. I'm going to change those capacitors, cross my fingers, see if this tube noise goes away. The thing that's driving me here, and there's a couple things driving me. One is I'm a persistent individual, and I don't like to let things go like this. I just don't like it. I really don't. I keep thinking of, there's another thing I can do. I stay in that state for a long time, trying all kinds of stuff, because I just don't like to give up. Number two, this is a really nice radio, beautiful cabinet. It's nice. It's very nice. And the sound, when it works right, sounds quite good. So, the rest of it is in good shape. What a shame that such a thing like this be abandoned at this point because of some relatively minor problem in the tube sockets, if that's what it is. Okay, so I'm going to struggle away on doing these two capacitors first, and then we're going to try the radio and see if any difference has happened. I don't give a lot of hope to this, but I think I'm foolish to not try it at this point, even though my theory is so weak. It is all I've got next to the essentially destructive process of removing a socket, which is kind of what's next. Okay, capacitors. So the method I'm using here to identify which of these terminals is the terminal of the capacitor I'm interested in is a pretty simple thing. I have a light shining here, and then I'm just looking from this side. I'll see if I can shove the camera in there. I may or may not be able to do this. Here we go. I shove myself in here, and then I look at the trace through the board, and then you can see, you see the big capacitor. Wait a minute here. There we are. The big capacitor there that I'm going to work on. You can see the trace right through the board. You can be pretty sure about what's up. What I actually do, I'll show you what I do here. So I'm looking in here, I'm moving my finger around, I can see my finger. And then I go, oh, right there. That's the one. That's the one right there. So that's how we do that. So there's no guesswork. It's out. 220 volt, 0.22. That looks fairly well sealed. Or is this a sign of damage here? It's got this interesting compound that you warm this up slightly and it'll flow. You strike it with something, like strike it suddenly, it'll shatter. It'll flow and it'll shatter at the same time. It's weird stuff. Let's put them on the tester and see what we got here. I mean, I don't... Is there any way this is in good shape? I just can't imagine it. Should probably look on the schematic and find out what this guy was doing in there too. Okay, 50 volts. Open right up like a fan. Just fantastic. That's not what I want to see. I don't want to see that. 250 volt capacitor. 100 volts AC or 250 DC. 50 again. Look at that. You know what? This is behaving as if it's open circuited. That there's no capacitance in it. 250. Yeah. This is behaving as if there's no capacity. So let's measure it, because it's also showing zero leak, which, how can that possibly be? This is behaving like a brand new capacitor, but one with very little capacity. So 0.22 is going to be in this range here. So now I'm going to turn the control. Whoop. Let's go back and do that leak thing again. And I had this set for electrolytic. That's probably why it didn't show the leak. Let's watch now. 50 volts. Yeah, okay, that makes perfect sense. It's shot. Now, is this killing the radio? Is this responsible for the problem? We don't know. We don't know. A little leak like that, a few electrons sneaking through, doesn't really matter. We don't know. We don't know. 0.22. Let's find this on the schematic. Oh, it took me a long time to find this capacitor on the schematic. But here it is here. C181.22 microfarads. It's the only 0.22 in the whole radio. There it is. What's it doing? So it's in the feedback circuit coming from the speaker, feeding back into the volume control. Yeah, into the volume control here. So this is part of the distortion reduction technique used in this radio. It's extremely common. Feedback is extremely common way to do it. Very, very effective. So now, what if this guy's capacity isn't high enough? Well, then it's not going to let through what it's supposed to let through, and the effect, the feedback effect, will be reduced. What if it's leaking? If it's leaking, so this isn't under a lot of pressure here. This is more like just an audio signal, I guess, coming through. So I'm not sure a leak would cause a big problem. It already has a 1000 ohm resistor across it, so this would have to be awfully leaky, like unbelievably leaky, before it would even approach this. So probably was working okay, but maybe not. We don't really know. So that's that one. And while I have this on the screen, why don't we hunt down the other one? The other one, yeah, I'm not sure. I have to take it out to see the size of it before, just like I did with this one. Okay, so that's what it is. Well, the second one is kind of interesting. You see it there? Take a look at this. So I'm pretty sure I didn't do any of that damage at all. What are we seeing there? And there's like, well, I know there's an abrasion. There's cuts. This thing's been to war. Its guts are coming out down below. Boom! Wow, this is I'm total surprised, because from above it looked like that. It looked like, put it on the camera there. It looked like that. It looked perfect. Not so perfect. So how does this guy test? I'd be a little surprised if it tests good. I wouldn't expect that to happen. Why would it do this? Jeez, I don't know. Just because it's old? I don't know. Sitting next to a tube that got stupidly hot because it's the wrong tube? I don't know. Okay, 50 volts. What do you say? It actually behaved normally. It didn't snap open so fast I would think it was shorted. Okay, let's give it 150 volts. Okay, so it's not opening now, just a crack. So it's definitely leaky, but it's not as bad as I thought. It's too leaky to measure its capacitance. The measurement won't mean anything. Let's find out where this guy was in the scheme of things here. Just look at the size of it. It's a 4.7 nanofarad. So it's a 4700 picofarad. 4700 picofarad. Okay, I'm going to look for it on the schematic. So the way I'm hunting down capacitors is not by looking through this. You go crazy and you can easily miss it. Looking at that, I'm looking at, because it has this component chart. Let me start on the other page actually, because the titles are over here. So it's a long chart. So you see capacitor, resistor, inductor, and it lists them here, gives them a number, and roughly locates them. So let's see if this works. C6 should be pretty much straight up here somewhere. C8. So this helps you find them. There's C6 right there. So now 4700. So what I'm doing is I'm looking through for 4700 picofarad. These are all in picofarad here. Nothing there. 2200. There's bound to be a few of them in here. I would guess. Here's one, 4700, and another one. But they're way over at the. I'm not going to say where they are. Number 111. Is it really up here? I don't think you're going to find C111 up here. So maybe I'm wrong about where. These charts are all done differently. So lots of 4700s here. Another one. 118. Another one, and another one. Oh my gosh, so many of them. And another one. Well, this isn't going to be easy to do it this way. Now the other way is to look at where it is in the radio and what part of the circuit it's in. So it's tucked right up tight to the output tube. It's there. Got to be there for a reason. So let's do the stare at the schematic thing and see if we can't find one here. Output tube. There's a 47 right there. This is probably what it is. Let's see if there's some more around here in this area. I'll bet you that's what it is. Oh, here's one here, right on the tone control. But this is nowhere near the tone control. It's a 4700 part of the detector, but I don't think it's not far from there. But I doubt that's it. So I'm gonna go on the theory that this is it. This is what's on there. How's that gonna affect the sound? It's tied to the screen here. Maybe it works its way right through the radio from there. Gets onto other tube elements, and maybe that's it. I don't know. I don't think so. I don't know though. I have great doubt that this is going to fix this radio. Okay, 4700, whatever it is, I'm going to change it with a new one, and maybe we'll test the radio after that. So I'm just sitting here thinking more about what I'm doing and realizing, boy, this really can't be the problem. This can't be the problem, because when I wiggle when I wiggle the output tube, sometimes there's a dramatic pop and loss of operation. But that's really a contact problem in the tube socket, I'm sure. Okay, so I got them on. Got two capacitors in there. Just finished convincing myself that this isn't going to help. Well, no surprise there, but let's just at least make sure the radio is still operating. I haven't killed it yet. Okay. Wires off there. Let's lay them down. Hearing the scratchy sound of the sandpaper here and a wire touching it. I'm becoming convinced I'm hearing the radio. Okay, let's get rid of these excess wires. Here we go. Everything ready. Volume down. We're on broadcast band here. Dim bulbs. Not plugged in yet. There we go. Dim bulb. No tubes in the radio. Hold on. No tubes in the radio. We need tubes in the radio for it to work. I'm trying my best not to wiggle these tubes as I put them in and out. The assumption that I tightened up the tube clips and I don't want to loosen them. Okay, now we're ready. They're all in there, right? Yeah. Okay, there we go. And this time we'll see the light a little bit. No, did not make the dim bulb glow at all. A little bit of volume. What's going to happen? I hear something. That's what's going to happen. Hey, there we go. Fixed. Got it. Pretty bad interference today. Yeah, terrible interference. Let's just try FM for fun. Wow. 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 Maybe there's no fun here. Oh, don't tell me the switches too. No, I mean this is bending the board and could be setting off stuff all over the place. Okay, seen enough. Okay, my capacitor theory. I think we throw that one into the garbage can. Yes, there's still another capacitor here, but really. I think a socket has to come out. If a socket has to come out, which one is it going to be? So they all look similarly. They all look similar. So the output one is only a 6-pin one. This one's a 7-pin one. This is a 9-pin. This one seems to have more dramatic problems, but it's probably because it's the output circuit. It's nothing to do with the socket being particularly bad. It's probably I'm guessing they've all suffered the same internal failure of some sort. If we look underneath, help decide. Getting a socket out is not the easiest thing because it has multiple soldered connections, right? And they're all, as long as one of them is hanging on. Well, there's not much sticking through here. And they don't appear to be like long wires bent over. And they look like wires, which is the weird thing. What is that? What is that? That is... So that's the shield. There's a metal shield up there, and this is the tang for the shield. So again, it just comes back to these little, they look like wires. They look like ordinary component leads. So how do you go from an ordinary component lead down here to a flat piece of metal that up into the socket that the tube is going in? So it's just more evidence that my thinking about what is going on inside these sockets is probably correct. So it looks like a fairly easy thing to get it out, in fact, except the center part. I have to suck away a bit of solder and then work on it. I think I can get it out. Now, which one? So we have this one and we have this one. This one's just a little more accessible. They all exhibit the same problem, so why would I worry about that? Well, I have to take 9 pins out. Here, I only have to do 6. Winner. Winner. I'm going to do that one. No, not 6. 7 plus the center post. Okay, so I'll do 1 or 2 prongs on camera here. And we'll, let me try this one right here. Work my way around and around and around. Okay, step two. Step two here. I've still got the tube in the socket, which is good. This is not going to go well. I think I need to put some pry pressure on here and just start going around and around and around. Slowly it'll work its way out. So to do that, I need to get work like this. This might be easier. I need to get under there with something. I think they're really tight to the board. What could ever get under it? Oh, that's under it. Oh, that's good. That put a lot of tension on it right there. So I just start loosening these up. Are we getting anywhere? That would be the question. Let's try that. Okay, so I'm trying to see if the bottom of the... So it is off the board a little bit. And what about this other one? Let's just see what these other ones look like. Now that looks like it's hard down to the board. There's another one here. Yeah, right down solid on the board. The one I've been working on is up. Now wait a minute, you know what? I shoved the tool in there to begin with. I think this was up to begin with because I shoved this tool in here and I went right in. So I don't know. It doesn't look like I got anywhere under here. Let me look at this. A couple of them are nicely unsoldered. Look at all the solder schmozzle everywhere in there. Oh my gosh. There's soldered tracks everywhere now. Yikes. That's another way of saying there's a good chance this is all shorted out. Boy, oh boy, oh boy. Yeah, it'd be better off. I'm going to continue to remove the solder. I think I really got to get rid of more of it. I think it's just about ready to pop out. There, I think it just went. It's gone. It's out. It's already out. Come on. What's holding it in there? Looks like it's held in by this lower much. Not much at all. Come on, let go now. Just almost out. Out. It's out. Dun da da da. Let me just get a grip of it here. Okay. It's very hot to hold. What exactly is going on down there? I don't think the construction is anyway like I thought. Let's take a closer look. Okay, let's get a good close look at this. See what is going on with it. There's a lot more to it than I would have expected here. Oddly shaped. Looks like this center ring. Looks like this center ring here is holding everything. If you took this ring off, all these clips would fall out. What's holding the ring on? It's probably glued on there somehow. Break it if I yeah, it doesn't want to come off. Well, it all looks like one piece of metal to me. What exactly are they doing here? Trouble angling this the way I want it in the camera. I don't know, it looks like one very carefully shaped piece of metal. Plenty loose and wiggly in there, most of them anyway. Seems to be a feature of all these. The terminals have to be kind of loose. The thing is, if you, in this case, you plug the tube in there. I guess it's a little different here because this is in a circuit board and not point to point. So with this in the circuit board, every time you drive a tube in and out, which is not something that happens often in the light floor radio, it's not supposed to anyway, you'd be stressing these. These are also going to conduct the tube heat right into the solder. I really can't see why this wouldn't make a contact, but we can certainly find out now what kind of contact you can make with this. Let me find the original. This is the original. Here we are. So the X is on it. It's the original tube. Don't use it. Let's put it in here. And what I'd like to do is measure the resistance between here and the tube, but how am I going to do that? I think this tube might have an internal connection between pins 2 and 7. Is that true? Maybe thinking of the wrong tube. So this is a 6AQ5. I think it does. I think it has an internal connection, which might be useful here. 6AQ5. Just bear with me a second while I check it. TUV QRS 6AQ5. Between 1 and 7 there's an internal connection. So I can, so this will work. 1 and 7. So I'm gonna run the ohm meter between pins between pins 1 and 7 and then fiddle around. See what we got. Just one and 7. So what I'm expecting is if there's contact problems in here in any way, shape, or form, it's going to show up here on the ohm meter. Look at it. It's a thing of beauty. Duh, oh, stupid me, what am I thinking? Wait a minute, that shouldn't show a short. There's no tube in it. What's happening here? Crazy meter. Okay, let's try again. Check it. I didn't check it this time. That's better. Open circuit. Full of false readings. I almost got fooled by false readings. In you go. Okay, now. So that could be 0. It says 0.2. It could be 0. And wiggle the tube a little bit here. Looking for something a little more dramatic than that. Now, is this really valid? If there's something going on, would I see it on here necessarily? I would think so. If I pick 2 pins that don't have any trouble. Let's try something else here. Okay, this is somewhat of a crazy test, but what I've done here is I have the socket here, and I picked the 2 pins, 1 and 7, that are internally shorted. So this should just go in and go out. This should be a short circuit when the tube is plugged in. The short is in the tube. So right now these are not shorted, they're open. This gray wire is going to my audio system. We're going to listen to this. This wire is going nowhere. I take it off. So that's just the lead to my audio system. Just you can just see the 2 clip leads just going there. So it's open circuit. So if we turn the volume up now, you hear a little bit of a hum, but I want it louder. So I have this. This is just a wire just going nowhere. It's just over here on the bench. I just want to increase the noise level. There. Now my thinking is, if if I short these out, that noise is going to go away. And plugging the tube in should short them out. And as I push the tube in deeper and pull it out, that short would come and go if there's a problem. If there's a problem. So there'll be some initial contact here. There, it's gone. Just I haven't even sunk it in yet. It says something about the quality of the contact on the, and I just not even shoving it. Okay, now we're gonna shove it in. Listen carefully. You hear a thing. Silence. So my theory on this is wrong. I thought this was two pieces of metal joined somehow inside here, and that the two pieces, the joint had come loose. That's a mechanical thing, and that's what was going on. No. So what is going on? All cold solder. I've resoldered this a couple times. It didn't seem to fix it at all. Thousands of microscopic breaks in the trace under the radio here. No, that just can't be the case. Just can't be. So I've now essentially convinced myself it's not what I thought it was, and I'm left completely unaware of what is going on with this radio. Why it's doing what it's doing. Could it be if I put this back in, the problems are going to be solved? Is there some kind of shorting going on in here? Let's take a look at that possibility. Okay, I'm just going to take the sound off here. We don't want the sound on. Put this way up on, say, 20 megohms here. Just pick one lead. Check the meter. Yeah. And the big ground thing in the middle. 200 million ohms. Check it. $200 million. That's a big number. Nothing whatsoever. Gotta stop and think what to try next, short of just putting it back in. Okay, I let enough time go by for another idea to come to mind. Why don't I plug this in, pretending it's a tube. Then we'll read the resistance from the contact here to the contact there. On each one of these. On each one. So if I can get it down to 0, I can clip this like this a little bit. There. Look at that. Stable as can be. You know, when you're looking for trouble, you're hoping to find it. When I hooked up to this, it moved. It's giving every indication of making just a fine contact. take one. Every one of these is coming through just fine. What are my options now? Best option is put this back in the radio. See what happens now. Okay, it's going back in. Now, just before I go and stick that in there, what are the chances that the top of the circuit board has become conductive? The chances are really, really small. That's what the answer is there. But before I put it all back together, let's check that and just see if I can find the leads to my voltmeter here. This may seem like the craziest thing, and the reason is because it is kind of the craziest thing. Got this on the 200. How did that happen? I touched this, didn't I? I must have bumped that. Or I'm touching this on my meter, my wonky meter. Maybe that's what happened there. Yeah, it's not it. I think I tapped it again. Tap the leads together. Yeah, there's nothing here, nothing going on. That's the acts of a desperate man. That's what this is. Center post to drop in. It's all gnarly here. Okay, well, I think you get the picture. Oh, there it goes. You get the picture. I'll solder that guy in. Okay, so you're looking at the bottom of the tube socket. I've already soldered the center post a bit to make sure that it's stable. You know, I guess when they originally made this, these things I'm soldering in here were probably quite long, and they cut them off. flush with the solder, of course. So they're kind of barely coming through here. A little bit of trouble getting the solder onto that. There's a fair bit of metal. This one, the solder's not grabbing very good either. This all looks very funny to me, just the way the light's reflecting here, I think. Yeah. Okay, I'll solder this in a little better. Well, that looks good to me. Okay, so it's kind of a big moment coming here. This fixed the situation with that tube, then they're all can be repaired this way by popping all the, I don't know why, but I don't know why this would work. Okay, now tube. Where's the tube? What did I do with it? The good tube. The good tube. Uh-oh. Uh-oh. Good tube's gone missing. This is the one here. There's no X's on it. Going right in. Trying to go right in. I don't know what's going on there. Okay. Just nervous. I'm nervous. Nervous. Okay. Power plug. Here we go. Broadcast. Volume down. Dim bulbs first. Okay, dim bulbs behaving normally. Good. Full power. Oh baby, turn it up. Holy smokes. Now that could be a different tube. Oh, it's something else completely. there's so many things out of sorts. You know. So what's happening here? If I fixed one of them and the others are all buggered up? No, look at that. Shit. So tomorrow I'm going to work on another radio. I think I've had it with this one. Hi. That's my answer to that right there. Jim, what's wrong with this radio? I don't know. I don't know. Something serious. So, yeah. That's enough for this for now, or I'm going to start losing my religion here. Another radio. Set this one aside. Maybe something will, maybe some magic idea will show up here. I don't know. Holy smokes. Yeah, I'm just trying to recover from my frustrations here. So this may be the last video on this radio. Very seldom have I gotten to the point where I have to abandon a radio, but I think this is one that I'm out of ideas. Okay. Well, thanks a lot for watching the craziness. The next radio is somewhat similar to this one. Oh no. See ya.